Hello, today we're starting Unit 7's 7.1 Introduction to Air Pollutants. The main thing we're going to be looking at is being able to explain modifications to an experiment or to identify sources and effects of pollutants. That's our main learning objective. Air pollution basics. Basically, you need to write about air pollutants, not just air pollution as an idea. In other words, specific molecules and particles, not just, oh, air pollution is bad. In 1970, there was an act called the Clean Air Act that identified 6 specific air pollutants. They're called criteria air pollutants. They are what the Environmental Protection Agency is required to set acceptable limits for, monitor, and enforce those limits. For example, sulfur dioxide. It comes from coal combustion, mainly for the production of electricity. It's a respiratory irritant. Sulfuric acid is one of the things that comes out of it. It's also one of the main things that produces smog. Nitrous oxides. Nitrous oxides meaning NO and NO2. Also, all fossil fuel combustions produce nitrous oxide. Why? Because coal comes from life, and sulfur comes from proteins. Nitrous oxide comes from both proteins and DNA. Nitrous oxides are important in the production of ozone, photochemical smog, and acid precipitation, which we'll talk about more today and later in another day. Carbon monoxide. You have to use these words. Incomplete combustion. Complete combustion gives us CO2. Incomplete is carbon monoxide. It also leads to the production of ozone. And if you get carbon monoxide, it makes it so that you cannot get oxygen into your blood and you die. Another one is lead. It's from metal plants, not plants, but basically if you have something producing metal, it produces lead. If you have waste being produced, it is a neurotoxin. You get lead in your system, you stop being able to think, or you are not able to produce nerves or brain tissue. Ozone there's 2 types of ozone. The stratosphere is the good one. The troposphere is terrible. That's the one we're at. Ozone in the troposphere is a photochemical oxidation of nitrous oxides. When you go down the 2 freeway towards downtown LA during the summer and your eyes start hurting or your lungs start hurting, that's ozone. It's smog and plant damage. Particulate matters. Basically, particulate matters is any time fossil fuels or biomass are burnt. It irritates. It increases the chance of asthma. It's why smog gets so thick. Air pollutants versus greenhouse gases. CO2 is not one of the 6 criteria pollutants in the Clean Air Act. However, in 2007, the Supreme Court found that EPA could regulate greenhouse gases, and so it started to do that in 2009. CO2 does not directly lower air quality from a human health standpoint. It's not toxic to organisms to breathe. It's not damaging to the lungs or eyes. It does not lead to smog or decreased visibility, but it is a greenhouse gas. It leads to Earth warming, and thus an environmental and human health consequence based on the Supreme Court ruling. Bottom line, in apes, if you're asked about an air pollutant, it's not asking about CO2. Stick to the air pollutants on FRQs, which is sulfur dioxides, nitrous oxides, ozone, and particulate matters. Talk about those if it asks about air pollutants. Coal combustion. It releases more pollutants than any other fossil fuels, and it's still 35% of all global electricity. It releases carbon monoxide, carbon dioxide, sulfur dioxide, nitrous oxides, mercury, arsenic, lead, and particulate matters. often other toxic metals in it. Impacts of sulfur dioxide, we'll talk more later, but it's a respiratory irritant. It causes inflammation of the bronchioles, in other words, the lining of your lungs, causes asthma and bronchitis. Sulfur aerosols, in other words, sulfur particles, block incoming sun, reduce visibility, and photosynthesis. It forms gray smog and combines with water and O2 to form sulfuric acid. When that comes down, it can be nasty. So nitrous oxides is released by combustion of anything, especially fossil fuels and biomass. NOx, if you hear the term NOx, it refers to both nitrous oxide and nitrous dioxide. NOx. Nitrous oxide can become NO can become nitrous dioxide by combining with either ozone or with oxygen. Sunlight converts nitrous dioxide back to nitrous oxide. And so nitrogen plus oxygen gives us nitrogen oxide. 2 nitrogen oxides gives us, plus oxygen gives us 2 nitrogen dioxides. Human and environmental facts of nitrous oxides: it's respiratory irritant. It leads to ozone formation, which leads to photochemical smog, and it combines with water and oxygen to form nitric acid, which causes acid precipitation. The EPA, before the Clean Air Act, lead was a common gasoline additive. Why? Because it made the car run smoother. EPA began to phase out lead from gasoline in 1974 because lead causes problems. Vehicles made before 1974 were required to have, made after 1974 were required to have catalytic converters to reduce the amount of NOx and carbon monoxide and hydrocarbon emissions. Also known as a neurotoxin, means it damages the nervous systems of humans. And you can see here, after 1980, the amount of lead significantly went down to where it's almost non-existent today. Primary versus secondary. Primary is what comes directly from the sources, such as vehicles, power plants, factories, and natural sources, such as volcano and forest fires. They're NOx, carbon monoxide, carbon dioxide, volatile organic compounds, anything like gasoline or something, or alcohol, or that spills and then vaporizes, that's a volatile organic compound. Sulfur dioxide, particulate matter, hydrocarbons, those are all primary. Secondary pollutants come from primary pollutants in the presence of sunlight, oxygen, and water. So primary becomes secondary in the presence of sun. They occur during the day, especially in the afternoon, because sunlight is required to cause their formation. One of the biggies is tropospheric ozone, sulfuric acid and sulfates, nitric acid and nitrate. So, a practice FRQ. EPA scientists performed an experiment where coal was burned in different chambers at varying temperatures to see how it caused the formation of NOx because of the coal combustion. So, can you explain how the results of the study would be expected to change if the same experiment was repeated with natural gas, with methane? Hopefully that was helpful. Thank you.